I've opened up states data that I've created for this tutorial and some other tutorials here for SPSS, and you notice it has the information for the 50 states and the District of Columbia on several variables. And these data are a little old, they're from about the 1980s or so. The first thing I want to do is show how we go about creating a scatter plot with these data. I'll come up and I'll click on the graphs chart builder to open up. Just go ahead and click OK on this message, and what we have here now is the chart builder window here open before us. You notice we have down here the various charts we can choose from. I'm going to click right on Scatterplot, and the first one is what we're going to use, the simple scatter. What I'm going to do is click and hold down the left mouse button and drag it up to this gallery display here, and you'll see it's a simple scatter plot, which means 1x by 1y, so the independent variable x along the x-axis, and of course the dependent variable along the y-axis like we want. What I'm going to plot here is going to be a variable young moms, and you'll see in a moment that this is the percent of births to women or to mothers under 20 years of age in a state for this year. And I'm going to also bring in the education 12 variable, and this is what this is. Edu 12 is the percent of the population with 12 plus years of education, and you'll notice then the variable labels here appear right there, and what you see now is kind of a general quick little snapshot of what this will generally look like. Let's go ahead and click OK, and you notice now it jumps to the output window, and right there is our scatter plot that we just requested. Now, one of the things I'll recommend is when you create your variable labels, make sure the variable labels are ones that you would want to put along the axes labels for your scatter plot. So if it's not quite the variable label you want, how to display here, go back in and change that in terms of your data editor. But while this is a fine for a general scatter plot, it doesn't really look as nice as perhaps we would want that. And what we're going to do here in a moment is, first of all, get rid of these grid lines. I'm really not a fan of having grid lines. It adds a lot of clutter and to the scatter plot, and I think it makes it more difficult to interpret a scatter plot. And also what we're going to do is change then the font that we have here, as well as changing the title of the scatter plot. So let's go back and execute the scatter plot again, going back up to the graphs menu, click to open that up, come down to select chart builder. Again, you can close this dialog box, but I tend to by just clicking here so it won't show again, but I tend to show it again so that students can see what might come up and how to handle it. So what we're going to do now is change a couple of the options that we have for us. Now you'll notice as we go over here to the chart appearance, I'm going to click on this tab right here, and what it's currently doing is using the default custom the default options for the setup for the display of the scatter plot. I want to click in this box here to use customs, and I can change the at this point the color we have here and some other things. But what I'm going to do here is just, first of all, just deselect the x-axis grid lines, deselect the y-axis grid lines. You notice now it opens up the scatter plot a little more. And also what I'm going to do is I want to put a little box around, or a frame around the scatter plot itself. I think it makes it look a little nicer when you can see where the plot space ends and begins. So I'm going to click here on the inner frame, and notice by clicking inner frame now I have a complete box there around the data points, and I can unclick that if I wish. I can put a frame around the entire plot by clicking on outer frame. I tend not to like that as much, but I do like to have the inner frame. So let's go ahead and then select the inner frame and make sure you turned off the axis grid lines. And now I'm going to click OK. And as we scroll down, we see the new version of the scatter plot. I think it looks much cleaner, much easier to see than the general negative trend that we see a fairly linear trend between these two variables. And now we have our frame around our plot area, which I think really nicely sets off then the data points and that space around it from the text. Now let's go ahead and change the text. The first thing I'm going to do here is double click somewhere on the space of the plot. I'll go ahead and deselect that and show you again. Move your cursor on top of the somewhere on top of the scatter plot and double left click, mouse click, to open it up. This is now the chart editor where we can actually change some of the things we see in the chart. I'm going to just first of all click on the title, and you notice once I click on the title, pops up is the font that's used. I'll click over here so you can see that again. Let's go ahead and double click on it to activate it. You notice there's nothing displayed here, so I'll click once, left mouse button, to select the title, and now you notice that I'm writing something, a memo or a report. It's in Times New Roman, and I want the font of my figure to look just like the font we have in the report. So I can click on Times New Roman, and I can come up here under this area right here is the font size. Click on that, and let's make it a 16-point font size, fairly large. Now it also is automatically bolded. I don't care too much for the bold, but that's just my personal preference, so I will deselect the bold. And what I also want to do now, so now I've changed the appearance now of the text for the title. I'm also going to change the title itself. So let me go ahead, click and drag to highlight all of the text within that title. And I'm going to change the title to table. If you have multiple tables, you want to number them. I just have this one table here. Table, scatterplot of state births to young mothers by educational attainment. And if you have the year here, let's see, I'll make it 1984, 1984. While the education data is 1980, it's only collected once every decade, I believe. We see here for the births to mothers that are under 20 years of age that this is data for 1984. So I'll put in 1984 since that's the year for my dependent variable. And that's how I go about. I'll click somewhere else now to unselect then the title, and that's how we can go ahead and change the title. What I'm also going to do here now is change the font for the text, the labels for the X and Y axis, and also the numbers here that are shown along these axes. So let me move the cursor on top of the title for the Y axis and just click the left mouse button once. I'll come up here to change now the font to Times New Roman. I'll make this, let's make it a 12-point font. And what we'll do here is I'm going to deselect the bold. And so now you notice a much nicer looking, I think, let's make this 14. So I'll double click it again and come up to 14. I'll make it a font of 14. Play with this to see what looks best when you bring it into whatever package you have for your report or a memo. I also will click once on the font, the title here for the x-axis, and I'll change that font. Also Times New Roman. And let's also, again, a 14-point. I clicked out of it by accident. Let's go back to where I was. Double click it to activate again, get back into the chart editor. And let's also now change the text for the numbers, the font that we have here. So all I did was just clicked on one of the numbers for the y-axis, and up came the font options. Come down and change that to Times New Roman. Oops. And I'll make this a 12-point font. And you notice bold has not been. Do the same thing for the numbers down here. All I did is move my cursor on top of one of the numbers and did a single left mouse click, and up comes then the font that we have here. I'm going to change it now to Times New Roman and make that a 12-point font. Now these font sizes for the labels here and for the titles for the x-axis may be a little large, so you can change that, but I would take this and put that into, copy it into whatever software I'm writing my report in to see how it looks, and then come back here and modify the text till I get it just right. Now another thing that we can do here is change the color of our data points. This as a gray is what's chosen, which is just fine. Actually, I think it looks pretty nice, but I'll just show you how to quickly to change it. I'm going to move the cursor on top of one of these dots for one of the data points and left mouse button click, and you notice they all are selected. Now when I do that, I can come up here to the color palette. I'll click on this down arrow button, and now you notice here more of a darker black that we had instead of the gray that was the default. When I'm done with that, I can go ahead and close the chart editor. At this point, I can save my output as an SPSS output, but I can also move the cursor on top of it and do a right mouse button click now, and I can copy. And I would choose copy as an image. When you copy it as an image, then you can paste it as I don't know if it's a JPEG or a PNG file type, but we can then paste it exactly as we have it, see it here into our data, into our word processor that we're using. So again, if you want to copy it, move your cursor on top of it and do a single right mouse button click, come down to copy as, and I would choose copy as image. And that's how you create a nice looking scatter plot in SPSS. Using the same state's data that we were using for constructing a scatter plot, we're going to now show how we can go about generating Pearson's correlation coefficients for quantitative variables. We'll come up under the Analyze menu, so click once to select and open up the Analyze menu, and we'll come down to Correlate, and then we'll move right over to Bivariate. We're just going to generate bivariate correlations. Now let's just use the exact same information we used for constructing the scatter plots just showed you. Let's come down and we'll select Young Mom, birth to women under 20 years of age, and I'll click on the arrow key to bring it over. And the order in which you bring your variables over will be the order in which is displayed within the output here. And I'll come back up here and choose Education 12 and bring that over. And not changing any options or anything else here, we'll just go ahead and click OK. Now you notice what is generated here is a matrix of for the correlation coefficients. Now you notice there actually are two values that are reported here, but if you look at these values, this is the exact same thing that we see down here, and you notice that there is a ones that are plotted along here. So what we notice is what's above and to the right of the ones diagonal here is the mirror image of what's down below it. And so if you're reporting then a scatter plot, a correlation matrix, you would just want to report just the correlations themselves. I wouldn't report the entire matrix with the ones or with the values that are up above and to the right of the ones. So what we see here is there's a negative 0.785, that's your Pearson's correlation coefficient, so a very strong negative relationship between education level, or educational attainment for a state's population, and percent of births to women under 20 years of age. What also is generated here is a statistical test for significance, or hypothesis test that we see here is generated. And we notice here that with a two-tailed test, and we see that the correlations are flagged here if it's less than 0.01, so it'd be significant at a 99% confidence level. So this does indicate then that this correlation using this particular hypothesis test is statistically different from zero. So we have a statistically significant correlation between these two variables. I tend not to like to use then, though, the significance test for Pearson's correlation coefficient. Instead, in another tutorial, I'll show you how to generate a regression model, and that's what I tend to like to use for hypothesis testing. I like to use the correlation coefficient merely for the strength of the association, but this is the automatic output that we see here. I'll come back up here and I'll generate the same output again, but I'm going to make one slight little change. If we go back to what I said a moment ago, I don't like to use the hypothesis tests that are generated here. I will just turn off flagging significant coefficients or correlations and click OK. Now you notice it's the exact same output, but now we don't see the asterisk next to the correlation coefficient itself, and that just makes it a little cleaner for me. But if I were generating and reporting correlation coefficients, I would not report the hypothesis test. Instead, I would generate a regression model, and I would report then the hypothesis test for the coefficient instead. While we generated a correlation for one particular pair of variables, we can also include multiple variables in the same correlation coefficient. So I'm going to go back to Analyze, come back to Correlation or Correlate, click on Bivariate, and now I'm going to add some other variables. Let's say I'm interested in knowing what the effect of perhaps the poverty level is on a correlation between poverty level and births to young women. Also perhaps the unemployment rate. Let's choose perhaps also, let's say the number of marriages per capita. Whatever variables I think might also be interested in terms of correlated with the dependent variable or correlations with the independent variables as well. And I'll click OK. Now again, I have already turned off the flagging of significant correlations, so you notice then there are no asterisks here in this table. But if I look at this first column here then reports the correlation of the dependent variable with each of the independent variables. Now you notice then we see a rather strong positive correlation between percent of persons below the poverty level and births to young women. We see a fairly strong correlation, positive correlation between unemployment rate and births to young women, and virtually no correlation between the number of marriages per 1,000 population and births to young women, a correlation coefficient of only 0.006. But we can also see now, if we look over to the other columns, how each of the independent variables may be correlated amongst themselves. But this is how we go about then generating a correlation matrix. If I were reporting this and I wanted to report all the correlations into one particular document, what I would do is generate then this correlation matrix with the same variable names on the columns and on the rows, but I would report only the correlations that fall below and to the left of the diagonal of ones, and I would also only report then the correlation coefficient itself for each of these variables. Now you notice the sample size is the same for all of these variables, these pairs of variables, 51 cases, so I put somewhere perhaps in a footnote that the sample size equals 51. But this is how we go about then generating bivariate Pearson's or correlation coefficients.